Hi, this is Tony Northrup for Train Signal, and in this video lesson I'm going to cover identity management for the SSCP certification exam. The first thing I'd like to talk about is user versus group management. Now, in a role-based access control system, you have user accounts that are assigned to individuals and groups that represent roles. And these roles represent job roles such as accounting, managers, East Coast office employees, West Coast office employees, and so on. Typical enterprise can have thousands of groups and maybe tens of thousands of users. For any given resource, whether it's a file or a printer or an object in an Active Directory, you can assign privileges to that object to allow different subjects, different users or groups, to exercise rights on it. You can make a file read only to everybody, but write only to members of the accounting department. Or you could assign those same privileges, but allow Mary from Human Resources to also edit a file, even though she wouldn't normally have access. So when we talk about user privileges, we're assigning privileges to a specific individual user account. And as this slide points out, this is not a scalable technique. And it's honestly, it's kind of an amateurish mistake, but we do see it, especially in small organizations. You know, imagine a small publishing company that has 5 employees. They might have one employee who handles shipping all of the books and another employee who works with the particular authors. If you're good about assigning file permissions, you might allow the guy who's doing shipping to access the printer for the sake of printing out labels and to read information from the customer database so we can pull addresses. You might allow the customer relationship guy to actually update that database. But I bet you're not making roles for shipping department and customer relationships management department. You're going to regret that eventually when the company grows and suddenly you have 10 different shipping people, and every single time you need to go and find every permission that's been assigned to the first shipping guy and make sure that employees 2, 3, 4, 5, 6, 7, 8, 9, 10 all have those same privileges. So that's what I mean when it's not scalable. It works okay in small numbers, but as a company begins to grow, it becomes impossible to manage all of it. It's also really hard to start taking away privileges. Imagine that shipping guy moves to a different department and he shouldn't have the same rights anymore. Well, you'd have to go and figure out every single resource that he had access to and take it away. So if the company had 10 printers, you'd have to go to every single printer and change the access control list. You don't have to do this with group privileges. You just assign the shipping department rights to read the customer database and to print. And then you move people in and out of the shipping department group. This is role-based access control, and it makes way more sense than user-based access control, to the point where nobody recommends doing user-based access control. It's a good practice to create very granular groups. Think about the smallest unit of work and make a group for that. For example, a small business might have one accountant right now. You could and probably would create an accounting group role, and you could assign permissions to that. But in addition to that major accounting group role, you could also have accounts payable and accounts receivable. Now you could put both the accounts receivable and accounts payable groups into the larger accounting group, and if there are resources where you want everybody in accounting to have access to it, by all means, use the accounting group to assign those resources. But if there are resources where only accounts receivable should have access, you would have that more granular group to assign access to it. So be forward-thinking when you're planning out your roles and groups. Remember that companies grow, and you don't want to have to go back and reassign all the privileges that you assign to the accounting department just because you get a second accounting guy. It won't scale. It would be difficult. And most importantly, it's really prone to human error. You're going to overlook something, and that leads to vulnerabilities. So notice that last bullet point on this slide. Put the users into groups, and then use the groups to assign privileges. This is the only way that scales. Now let's visualize this example. If you have a single big group, this is the accounting group, you could assign them access to resources. They have full access to one folder and read-only access to another folder. Now imagine that somebody creates resources that should only be accessed by accounts payable, AP, or accounts receivable, AR. Well, at this point, you'd have to go in and start making more granular groups and then assign the appropriate permissions to each of them. Saves you time if you do it ahead of time, but sometimes you end up having to improvise. You do end up making changes later and breaking groups down, and it's never too late. You can always do that, especially if you're doing it for new resources that are appearing, and you don't have to go back and reassign privileges for existing resources. Now let's talk about separation of duties for individual users, but especially for IT people. It can be a really good idea to create multiple accounts for individual users depending on the type of task that they're going to perform. And because most of us are computer guys here, we can think about separation of duties for IT people. If you're a domain admin and you need to go around and update every resource in the domain on a regular basis, you have these incredible privileges that misused could bring down the entire company. Well, you don't want to log on to your desktop computer and browse the web with that account, because if you screw up and get some malware on your computer, the damage it can do could be devastating. It could be really awful, and you don't want to be held responsible for that. So for that reason, if you have a highly privileged account, you should create a second account for the person that has lesser privileges. In other words, you need an account to do your day-to-day stuff. Filling out paperwork and filing your expense reports. You shouldn't be doing that with the same account that has the power to delete every user in the organization. And most OSs do this automatically for local rights. For example, if you log on to any recent version of Windows, Linux, Unix, it will create a standard user account for you, a standard token basically with fewer privileges, if the account you're logging into happens to have administrative rights to, say, install new software. Then if you go to do something that requires administrative rights, it'll just prompt you, or maybe you have to go through some manual steps like running the sudo app in Linux to elevate your privileges. In Windows, it's the user account control dialog box that appears to allow you to get higher rights and install software or configure an app to start automatically, for example. So for IT people in particular, it's really important to create separate accounts for both administration and regular use, and make sure that they have separate usernames and separate passwords, because you don't want one password leaking and then having the attacker realize that they could use that same password for the other account. So it's important that they maintain unique passwords for both accounts, though most systems don't have a way to require that. You can require people to change their password on a regular basis and prevent them from changing their password back to the same thing. But you can't say, hey, these two accounts are for one particular individual. Make sure that they don't ever have the same password. So you have to do that by a matter of policy typically. Just make it a rule and don't allow them to do that. Another common identity management topic is time restrictions. One of the ways you can limit access is based on the time of day or the day of the year. The most simple are logon time restrictions. If you know that a temp user is only going to be working from 9 to 5, Monday to Friday, well, set logon time restrictions so that they can only log on from 9 to 5, Monday to Friday. If they have to work on a weekend, well, you'll have to modify that and make an exception. But what you don't want to happen is for that user to get, a little sneaky and sneak onto the corporate network to maybe abuse it or access some files when they're not being actively monitored. But it's not just temp users. You should use logon time restrictions for every user account. Now, it's not always possible. A lot of workers tend to work different hours. They might work long hours one day, and you don't want them calling IT every single time they have to work on the weekend, so it might not be appropriate for everybody. But whenever you can, implement logon time restrictions. You can also grant temporary access by setting an expiration date on an account. For example, if you hire a contractor to work for 1 month, set their account to disable itself automatically after that period of the contract is over. Now, you might renew their contract, but as part of the contract renewal process, you should have a process for extending the expiration date of the account. Anybody who's not a permanent employee should have an expiration date set to their account. Otherwise, it's going to be forgotten, right? After that contract expires, how do you know for sure that the manager is going to call up IT and say, please remove this account, the person is no longer working with us? Well, they could forget. And if they forget, the effects could be devastating. that guy's password could slip out and be abused by somebody else. Or maybe you don't pay your bill on time and he gets a little irritated and logs into your network and decides to extort you. Well, set that expiration date on any temporary accounts to prevent them from being abused. If somebody goes on vacation and isn't going to be accessing the network, well, it's a good idea to disable their account for the period that they're going to be gone. Now, I'm throwing this in because I want you to be familiar with the concept, but I don't know of any company nowadays where people on vacation don't access the network. You know, wireless access has gotten so pervasive that we're all on our smartphones all the time getting corporate email and checking up on stuff. So I don't know of any realistic situation where somebody is never going to be accessing their account for a period of time, but know that it's a possibility. Now notice I've been saying disable the accounts. You should almost never delete an account. There's a problem with deleting an account in that you can't undo it, right? If you delete an account, it's deleted forever. There's no like recycle bin for user accounts. The recycle bin for user accounts is to disable accounts. Disabling an account keeps it around, and that maintains all of that user's encryption keys. Any information that might be associated with the account and whatever your directory service is will stay intact as long as you disable the account but don't delete it. It also allows you to better maintain an audit trail. And you know what? Maybe you hire that guy back and he can just resume using his existing account and you don't have to go back and assign all the privileges and stuff. You can just undisable the account. Now I'd like to really quickly show you how Windows Active Directory implements these identity management tasks. This is Windows Server 2008 R2 and the Active Directory Users and Computers tool, which is what you use to manage users. You can see a list here of different accounts that exist in the organization. There's only actually one account, and that's for myself. The rest are standard default accounts used by various processes. Editing the user profile here, you can see a lot of relevant information, but for identity management, most of it's going to happen on the Account tab here. Now you can see this first checkbox is selected by default. User must change password at next logon. That's because it's a new account, and presumably it has a temporary password assigned to it. Here you can see the account is disabled checkbox. And if I were to leave the organization, presumably an IT guy wouldn't delete my account, but he would simply select that checkbox. If I ever came back, they could clear it. If they ever needed to log on using my account, perhaps to access files that only I had rights to, they could undisable the account and then log on as me. You can control the log on hours by clicking the log on hours button here, and it opens up this dialog box. You can see that the blue areas permit log on and the white areas block log on. So if I knew that I was never going to be working on Sundays, I could deny myself access. Similarly, on the weekends here, and I'm not an early riser, so I could block myself off to prevent myself from logging on before 7. Again, it's not to prevent me from working, it's to reduce the amount of damage that somebody who stole my credentials could do. The roles that I'm a member of are configured from the Member Of tab here. And as you can see by default, I'm simply a user. So I'll cancel out of that now, and I will create a group which represents a role. Right-clicked, and then I selected New, and then Group, and I'll just call it Accounting. Now I can edit the accounting group and add my account to it. As you can see, the accounting group can also be a member of other groups. This would allow me to create accounts receivable and accounts payable groups and then put them inside the accounting group. Now that I've created a group and put a user inside the group, I'm ready to assign permissions. So I'll open up Explorer here so I can set permissions on a file. I'll create a folder for accounting, and then right-click it and choose Properties so that I can edit the permissions. On the Security tab here, I can configure the rights, and what I'd like to do is to grant the accounting group the ability to edit the file. So I'll click the Edit button here, and then click Add to add the group. I typed accounting and pressed Enter, and you can see it adds it to the list. By default, it doesn't have modify privileges, so I'll select that so that the accounting department can modify it. This is the access control list for the file, and because the accounting department wasn't previously listed and the accounting department is not a member of the administrators group, well, they would have no privileges because, as you recall, in a role-based access control system, anytime there's an access control list, it's deny all by default. So if it didn't appear in the list, it doesn't get any access. Therefore, by adding it, any user that is a member of the accounting group will have the privileges that I assign, and this is way more efficient than simply adding in individual users. As you can see, I am allowed to add users to the group and assign privileges. There's not a technical limitation, but it's simply not a best practice. It would be difficult to manage, so I'll remove that now. Now let's talk about password policies. There are many different types of authentication mechanisms, and we've covered them in a different lesson. Even though I'm not a huge fan of the password, I know it's going to remain the most common way to authenticate users. And you can do passwords so that they maintain some level of security. The most important element is to enforce password complexity and length. Most organizations will want their passwords to be at least 8 characters in length, but longer is better. Longer is better because brute force attacks will generally start with 1-character passwords and continue getting longer and longer. And each time you add a new character, well, the number of password permutations that a brute force attack has to go through grows exponentially. To put that in simpler terms, longer passwords are way, way, way harder to crack. Even going from 8 to 9 characters makes it much, much, much more difficult to guess. If you are guessing just plain lowercase a through z passwords, well, you can guess those a lot faster than if you have to throw in the additional combinations provided by numbers and special characters and uppercase letters. So a brute force attack that simply has to go through lowercase a through lowercase z and then lowercase aa through lowercase zz and so on can execute an order of magnitude faster than one that has to include both uppercase and lowercase and all those numbers and all those odd symbols. So in your password requirements, make users throw some of those things in there. That way, if somebody performs a brute force attack against you, they have a lot more work to do. It's going to take them a lot longer. They might still get there, but it could be a few thousand years before they crack a password. Many organizations also choose to enforce password expiration. This basically means you have to change your password every now and then. 30 days is a pretty common interval. I see 60 or 90 days on a regular basis too. Here's what password expiration does, and it's kind of a theoretical concern. Back when I was talking about those brute force attacks, well, if there were a system that simply allowed an unlimited number of requests from a password attack system, it would eventually get through it, right? It might take days, it might take weeks, it might take years depending on the complexity of the password, but it would eventually get through it. Now, if you force passwords to expire and users have to change them on a regular basis, well, the password cracking algorithm is going to have to crack it before the next expiration, because if the user changes their password, it has to start the whole process over again, right? So in theory, that's what password expiration policies do, is they put a time limit on the cracking attack. Otherwise, it could just go on forever. There are a few other benefits to changing your passwords on a regular basis too. If somebody does get your password, well, once you change it, they will lose access to your account. So it limits how long a successful compromise goes on. Now, it's not perfect. If somebody gets access to your account, maybe they have access to create a new user for themselves, and that means that they'll be able to continue to access the account using that new account that they created. But if you don't have permission to create users, or if they're not that clever, changing your password is going to be enough to block them out. One of the elements of forcing users to change their password is making sure they don't change their password and then just change it back to their previous password. So if my password's Sandy and then I change it to my other dog's name, Cowboy, I would be like, well, I'm never going to remember that as my other dog. I don't like to change my password, so I'm going to change it now back to Sandy. And that's a little trickery that users often do. So a common policy is to record a password history, and this password history is associated internally with the user account. And every time they change their password, well, the system goes in and checks to see if that password has been used previously. Of course, it's storing hashes, so you can't go in and look up somebody's old password. Passwords require a lot of maintenance. And recovering or resetting passwords is a really common one. Now, recovery kind of means you give the user their password back, like they forgot it, and you remind them, oh, it's your dog's name, it's Sandy. Usually nowadays that's done through a password hint that the user defines. So when you create a new user account in Windows, it'll prompt you to say, hey, give yourself a hint for the password, because then if you mistype your password a couple of times, the hint will pop up and it'll be like, hey, it's stupid, it's your dog's name. Resetting is a little bit different, and resetting is what most enterprises do with their accounts. They simply change your password to something new. You wouldn't want the IT guy that you're calling for help with your password to be able to look up your password. You don't want him to know your password. I don't trust that guy. Who knows? I probably use the same password on my Facebook and for my bank. So if he could get my password for the sake of recovery, well, he could abuse it too. So that's not the way enterprise password management systems work. They just allow the guy to set a new password for you. And in fact, you shouldn't tell that guy your new password. You should make him make something up. Usually they make up something really easy for you to remember, like 1, 2, 3, 4, 5. And then you need to immediately log in onto your account and change that password back. The reason it's immediate is he communicated that temporary password to you using some probably insecure mechanism. He probably just told it to you over the phone, which means somebody standing behind his shoulder heard him say the password, and somebody who's listening in on your phone heard him say the password. And anybody who heard it can then log in. Log right in, change that password, and when you're resetting a password for somebody, tell them to do the same thing. Account lockouts are another way to reduce the effectiveness of an attack. A lockout prevents an account from being authenticated after a certain number of failed authentication attempts. So often the number is 5. If you mistype your password 5 times, your account is locked out. Now, the account can either become unlocked automatically after a set period of time, like 30 minutes, or it can remain unlocked until you call IT and say, hey, my account's locked out, I forgot my password, and I was typing it over and over again. I remember now, you can just unlock it for me. So the way this prevents against dictionary and brute force attacks is those types of attacks will just keep trying different passwords until they get the right one. Well, after they try 5 different ones, it's going to lock the account out, and then it can resume in 30 minutes, but that's going to really slow down the process to the point where it will basically take hundreds of thousands of years to successfully guess a password. When you're setting up account lockouts, you probably don't want to set the same lockout policy for everything. You need to think about how you do it for different accounts. You need to determine whether you lock people out for cached credentials, which are what is used for offline access when they can't connect to an authentication server. You also need to think about service accounts. And service accounts are these entities that processes use to run. For example, a web server will have a service account so that it can connect back to the database server. The web server has to authenticate to the database server. So it has a user account just like a human being would. And it has a password too. Now, if the web server's account gets locked out, it won't be able to authenticate to the database server, which means your website won't run. And you know what's happening here? You're opening yourself up to a denial of service attack. This account lockout is supposed to improve your security, but some guy who has no intention of actually cracking the password could get your service account username and try the same password 5 times until the account's locked out, and then your website's down. So it would be a really easy denial of service attack. And for that reason, you typically don't automatically lock out service accounts. Instead, what you do is you audit them. Every incorrect password attempt is logged, and after 5, 10, 100 incorrect password guesses, a bell goes off and somebody in IT needs to go check it out and put a stop to the attack. That's how you deal with brute force and password guessing attacks against service accounts. One of the most important components is to educate your users. And here are just the big points that you should communicate to people. Tell them to never tell their password to anyone ever. That means if somebody calls them and says they're from IT and there's an emergency or there's a problem with their account and they need to get their password, don't give it to them. If they get an email from somebody, don't reply back with your password. If somebody instant messages you and says you've won $1 million, don't give them your password. Also, don't write your passwords down. I know it's hard to remember all these passwords, but if you write it down, well, suddenly somebody can see it and steal it. And you know what? In general, this applies to storing files on a computer, but there are systems out there. I use a password storage tool that provides some encryption and cryptography, and basically it protects all of my hundreds of passwords to different websites with a single password. So I feel like that is a necessary evil, but what we're really trying to prevent is people writing their password on a Post-it note and sticking it to their monitor, and this happens a lot. And sometimes people will get clever, and you know what they'll do is they'll like add an extra letter to their password, so they'll just remember like, I need to remove the third letter. But we're onto that game too. Don't write your passwords down, okay? They'll write them backwards too, and they're like, oh no, I used cryptography, I wrote it backwards. Nobody's ever going to guess that Sandy spelled backwards, and nobody's ever going to be able to figure out that my password is my dog's name, right? Don't write your passwords down, but if you do, put that paper someplace secure, and then when you have it memorized, destroy it. Like, don't just toss it in the trash. You know why? Because dumpster diving exists. Corporate spies go through other companies' trash looking for secrets. For real. They really do that. And they literally jump into dumpsters and steal bags of trash and throw it into the back of a truck. And generally, it's not illegal, because once you put your trash on the curb, it's considered public property. There have been lawsuits around this exact thing. So this really happens, and you really do need to shred or burn confidential data. If a user knows that their password has been compromised, they need to change it. That seems obvious, right? If they stupidly give their password out to somebody who is tricking them, well, they need to immediately change it. You also need to tell them to use a different password for every account. And again, this can kind of get unmanageable when they have 100 different websites, but it's important to let them know this. Don't let your web browser store passwords. People do this all the time because, again, you don't want to be typing your password all the time. But what happens is somebody just needs to get access to your computer, and then they can use your stored passwords to authenticate to lots of different websites. You know when this happens, it's when you use your buddy's computer to log on to Facebook and you let it store your password, and then he goes back on and he says, oh, I can log on as Tony on Facebook. Well, I'm just going to make a really stupid status on Tony's behalf, and then all my friends will think I've done something stupid. We always do these fake status messages things, and that should be less than enough to not let web browsers store your passwords. When you log on to a website and it prompts you for a password, just look for the HTTPS icon in the address bar. You'll also typically see a little lock icon that indicates that the web server has been successfully authenticated. And then once you see that it's HTTPS and that it's a secure connection, really look at the name of the website too. So if you're going to trainsignal.com, just make sure it says trainsignal.com and it has a little lock there. You need to train users to do this. If it says HTTP, that means that everything's unencrypted and the server's not authenticated. If it says HTTPS, that means that the communications are encrypted and the server really does have a certificate for the name in your address bar. But it doesn't mean that the name in your address bar is where you actually intend to go, so you also have to check to make sure that the name is valid. HTTPS authenticates the server, in other words, preventing a man-in-the-middle attack from being successful. And of course, finally, tell your users to create strong passwords. And here's what I mean by strong passwords. No words or names. Not your mom's name, not your dog's name, not your girlfriend's name. No birthdays, not birthdays encoded, not January 3rd, 1974 or 010374. No well-known phrases. You shouldn't say hasta la vista, baby, or have a nice day. None of that, because it would be too easily guessed. It's going to be in a password dictionary. And your password should be long, at least 8 characters. Next, include special numbers and characters, but not numbers that you care about, right? It shouldn't be your phone number. It shouldn't be your house number. It shouldn't be your birthday. It shouldn't be your social security number. They should be random numbers that you create. You should use special characters and don't just put them at the beginning or end of the password. And don't replace letters with similar special characters. This is something that we used to call leet speak because back in the early days of BBSing, which I was into in the 80s, people would set up filters that would block terms like hacking. So hackers figured this out, and to bypass these simple text filters, they started replacing the letter A with the @ sign, and the letter E with the number 3. And people still do this. Sometimes they think they invented it. They see the @ sign and they're like, I'm required to have a special character. I'm going to put that in instead of an A. And aren't I clever? I've met the requirements. But I showed the word password there written in leet speak, and this exact thing is in the password dictionary. And your password like that will get hacked. And in fact, password dictionaries will go through and take every word in the dictionary and just replace the letter A with an @ and the letter E with the number 3, and then they'll stick an exclamation point on the end of the password. They know to do this. They do it automatically, and if you do that, well, it's easy to guess and your password's going to get hacked. And finally, use uppercase and lowercase letters, but don't just make the first letter uppercase. Throw it somewhere there in the middle, because everybody makes the first letter uppercase, and again, if you do what everybody else does, your password is going to be easily hacked. My real advice is to use a complex random password generator, and just search for that on the internet. Just search for random password generator and you'll find a dozen different websites that will show you a password. The better websites will actually give you a list of 5 different passwords, and I don't like that the website knows my password, so what I like to do is I'll take the first part of one password and the middle part of another password and the last part of a different password. That way the website itself doesn't know it and it didn't get intercepted in transit. So I'd like to really quickly demonstrate how you configure password policies in an Active Directory domain. And once again, for the SSCP certification, you don't need to know how to do this on any system, but I find it helps people remember if I show them how it's implemented in the real world, just so it's not so abstract. This is a computer running Windows Server 2008, but basically all Windows computers have had these same policies since the beginning of time. Now, the first one you'll see here is password must meet complexity requirements. This is enabled. The minimum password length is set to 7 characters. Of course, you could change that. The minimum password age and the maximum password age force users to change their passwords. The maximum password age is pretty obvious. That's how often users need to change their password. The minimum password age prevents them from changing their password over and over again to restore it back to the original password. So with this default configuration, they would have to wait 24 hours before they could change their password back to an earlier password. Another way to prevent that is the enforce password history policy, which remembers by default 24 of their passwords, and when they change their password, it checks it against the last 24 passwords that they use to make sure that it's unique. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.